welcome back. We are right on time. We have a quite dense session now, 90 minutes, some pitches, but it's also meant to be an open opportunity for the audience to share reflections, even directly here in this session. If you have some, please do reach out to Ovidiu, who will be introducing himself and give us an overview from your vast experience in doing road mapping for the IoT space. So Ovidiu, thank you, a warm welcome, and over to you.
Thanks, Martin. So we will start this session on IoT and Edge Computing with a number of issues that are very hot for enabling technologies. So I will start, first of all, stressing once again the importance of convergence of technologies. So for the IoT community, convergence of technologies was a hot topic in the last few years. And we are very happy that we are seeing now the fruits of these activities on research that are coming to implementation. And we see more and more of these technologies that are converging and they are enforcing each other. So we see that IoT technologies and applications get support from the other technologies like artificial intelligence, edge computing, distributed ledger technologies, wireless and cellular, 5G and beyond, digital twins, and at the same time, IoT application reinforce these technologies and further develop these technologies and bring new features to these technologies. Related to edge computing, we see that actually edge computing is filling the gap between centralized cloud and the need for decentralized processing that is needed for IoT and industrial IoT, and for using edge computing in vertical and horizontal platforms, IoT platforms. At the same time, we see edge computing as an element that paves the way for IoT, DLTs, intelligent connectivity, and AI convergence. And now, if we move further to the flavors that we have for IoT and industrial IoT edge, we see that edge computing is the distributed computing paradigm, providing computation and data storage closer to the location where it is needed to improve response time and reduce bandwidth.
Ovidiu, sorry for interrupting you. Are you planning on sharing slides or not?
Oh, sorry.
Yes.
This was a very good point. Just a moment. You see my slides now, right?
Yes, we do. Thank you.
Thanks, Jean-Baptiste. So actually, related to the convergence of technology, this slide actually summarize the points that I made before. So artificial intelligence, intelligent IoT, industrial IoT, edge computing, distributed ledger technologies, wireless and cellular, digital twins, and the elements that we see more and more in IoT technologies and applications. We see the elements of autonomous, self-X, dynamic, scalable, neural technologies and topologies, swarm intelligence, tactile, and Internet of senses. So considering this, as I mentioned, we look at the different flavors for IoT and industrial IoT at the edge. And I mentioned the definition of edge computing. Then I will refer to fog computing, that is considered as an horizontal system level architecture that distributes computing, storage, control, and networking functions closer to the user along the cloud to think continuum. Very interesting mentioning of the cloud to think continuum. Then we have dew computing, which is another paradigm that represents the on-premises processing unit, software hardware organization, in the computing environment where the on-premises processing units provide functionality that are independent of cloud services and are also collaborative with a number of cloud services. Then we have another concept called Cloudlet, a trusted resource-rich processing unit or cluster of processing units that is well connected to the internet and it's available for use by nearby mobile devices. If we move in the domain of telecom, we see that the mobile edge computing, which was mentioned before, has emerged in the last years, and it's one of the pillars in the development of 5G and beyond. And here the computing at the edge of the network with proximity close to the end user that delivers ultra low latency, reliability and scalability. And last but not least, deep edge computing, which was presented for a number of devices that have increased intelligence and rely on the principle of distributed computing, with computing units having limited resources and depending on high efficiency energy consumption and connectivity functions. We will see that in the talks that we have after my introduction, the speakers will touch upon different flavors of edge for IoT applications and technologies. Then if we look at the architecture, actually this combination IoT and edge computing has to consider matching the layers of the architecture in these two technologies. From the point of view of IoT and edge, we see that the architectures are quite aligned and started from the similar points and concepts. Here I try to put first the IoT reference model that was developed over the last years. This is the two-dimensional model. And then I jump to the fog reference model that was developed by the Open Fog Consortium, which now is part of Industrial Internet Consortia, which actually includes, as you see, most of the same functions and the elements as we presented in the IoT architecture, which means the integration of IoT and edge like a glove in the future. As you see, we have the same type of layers, and vertical, we have the same type of functions that we have to address. So if we look at the model, the reference model, we see that we have a software view, a system view, and a node view. And we have as well a cross-cutting perspective. That means performance and scale perspective, security, manageability, data analytic and control, and IT business and cross-fog application perspective. Having this in mind, I jump to actually the more advanced 3D architecture for IoT that includes most of these views in the 3 dimensions that are considered for IoT applications. So on one side, we have the layers with 8 layers that include the parts related to the physical layer, network layer, processing, storage, abstraction, service, application, and collaboration. And we see that edge computing is already included as part of the processing layer and could extend as well to the other layers as the integration becomes closer and closer between IoT and the edge. On the cross-cutting function, we see some of the important elements that are related to trustworthiness for both IoT and edge computing, and on system properties are elements that apply to both type of technologies, from intelligence to interoperability, integrability, scalability elements. Then another element that I want to stress, it's actually the contribution that edge computing will bring to the evolution of IoT from the move of the centralized cloud-centric solution to more decentralized, federated, and then hopefully in next decade in kind of fully distributed computing architecture. Then in this kind of evolution, we see that the other technologies converge in bringing the features that are needed for moving to distributed architecture with federated learning that brings AI models close to the edge. Then with the role of the cloud that can have a federation aggregation role, and the collaborative work for IoT devices and discovery services. At the same time, it's important to see that a distributed IoT model at the next decade will include embedded AI that will support the shift from this cloud-centric, centralized processing and intelligence to more distributed intelligence and distributed IoT architectures. Then, in this context, we see that the developments of the technologies are supporting this transition from centralized to decentralized, with the developments in the AI-based components and devices that will become part of the IoT devices and components. And here we try to put a kind of representation of how this integration will be done in the future and how this will be applied then to the different applications that we call them Internet of Vehicles, Internet of Health, Internet of Robotic Things, Internet of Energy, Green Internet of Things, Tactile Internet of Things, Artificial Intelligence of Things, that actually will need to have and be based on a distributed architecture with new functions that are enabled by the technologies that are converging, like AI, as presented here, like distributed ledger technologies, like intelligence connectivity, like digital twins, like edge computing at the end. So, with this, I conclude my short introduction, and I would like to introduce the speakers at this session. So we organize the session in two parts. So in the first part, the speakers will have a short presentation of 3, 5, 8 minutes each, where they address a specific topic related to enabling technologies, IoT and edge computing. Then you can ask 1 or 2 questions at the end of the presentation. So they will answer to you a question related to their topic presented. Then when we conclude the presentations, we will reconvene into a panel where a number of questions will be addressed to the panelists. And then we open as well the floor to you, to the audience, for other questions that are of interest for you. So, thanks again for joining this session, and I will invite Antonio Skarmeta from University of Murcia to present his point of view, his view on IoT and edge computing, and how he sees the evolution of enabling technologies for the application in which he is involved. Antonio, please.
Thanks. Can you hear me correctly?
Yes, I hear you perfectly.
Okay, perfect. I will.
Yeah,
Yep. Okay, so basically, I will thanks. First of all, I would like to thanks for the invitation, obviously, to participate in this workshop, and also I would like to congratulate some of my previous colleagues because their presentation were quite, I would say, interesting, and it helped me a little bit also my own presentation because they already cover some of the topics I already mentioned. So basically, my point in my presentation will be focused on the interaction between IoT and the Edge and AI. Specifically on the way we understand the next generation of IoT nodes will behave based on these new capabilities that we are generating on these technologies. So, I mean, as I already mentioned, some of the topics already have been mentioned, but I mean, I wanted just to put them all together. I think that one of the technologies that I haven't heard too much during today's presentation is the impact that 5G is also providing to this new paradigm shift that is being producing now in that sense. So 5G, not only because of the communication part that obviously is important, reducing latency, increasing bandwidth, et cetera, but also because of the capabilities that is offering to have a very distributed processing scenario, I would say, on these technologies. And additionally, because of also the softwareization part that is already bringing, I would say, to the solution, that also helps, I would say, in most of these new mechanisms that we can generate on that stuff and on this kind of scenario. So basically, that is giving out the real highly distributed processing capability that allow this continuum that already have been mentioned a couple of times, but also having this possibility also appear new kind of challenge that we will mention later, for example, about how to efficiently and effectively manage the different computing and network resources that are available and that need to be now orchestrated and in an intelligent way, I would say. No? And also, I think also from the presentation from Atos this morning, I think we have also another important issue that is happening here is that we have this possibility, we have this capability, but now also we have a lot of new points of data introductions or the insertion of data to all the system that also need to be managed at different level, creating problems at security or challenge at security and privacy level, etc. So as I already mentioned, it's important this kind of coordination of all these processing mechanisms that can cover all over the continuum process that we are talking there. That also means that we need to create, and here is where AI is clearly providing, I would say, new possibilities of how to intelligently manage these capabilities, as I already mentioned, how to coordinate all this processing, and for example, how to decide when and where some of this processing need to be done. For example, depending on the context, depending on the conditions, depending on the needs that we can have at a certain moment, either based on a delay, on processing constraints, on security aspects, etc. So we need to harmonize all this, taking into account that there will be a lot of heterogeneity on these processing elements that we are having on this kind of scenarios. Okay, so basically, if we look at the research and innovation ahead that we can have because of this, here with this picture, basically based on some of the work that we are doing now is try to represent a little bit the new, I would say, paradigm of having many different kind of processing entities that could be from the sensor side, could be in the edge side, could be the cloud, it could be a combination of all of them in some sense, that need to be orchestrated in a way similar to what originally, for example, when we start with the internet, there was a way to need to orchestrate how to allow that the packets flow from the origin to the destiny. Now we need to orchestrate how the processing entities are able to be orchestrated from the beginning to the end of the transmission in some sense. So there's certain analogy, and that's why the peering issue that we are measuring here that need to be done between the different entities that are going to manage this processing unit in that sense. Obviously, in this process, as already was mentioned, also the idea of the tactile internet and the impact of the tactile internet in the future regarding about how to control, for example, objects remotely based on low latency, on local decision, etc., is clearly one of the key, I would say, challenges that can be cope with this kind of new technologies. As I already mentioned, obviously, all the aspects regarding to optimize specifically, and here introduce the idea of the intelligence issue is regarding the optimization of the offloading processing operation that can happen at different levels in that sense. But different levels that are not static, and this is quite important, is something that's going to be dynamic. If we're thinking about the vehicle that is moving around a city, in that sense, the needs and the processing possibilities can change over the process of over the travel time of the different device, happening that changing of network types, changing of conditions, for example, of context that make that also you need to take into account this in order to take a decision about how to do the orchestration of all the processing process. And also important is, as I already mentioned, more and more we are embedding intelligence on the IoT device, either in very constrained device. Now we are able to introduce certain kind of intelligence that also, and that will be important, will be able to adapt and evolve, I would say, in some sense, during the lifetime of the IoT, based on the interaction that the IoT is going to have with the environment, with the context, and with the other devices in that sense. And there, for example, on this management of the adaptation, I would say, of the capabilities of the devices or the edge, and the coordination of them is where, for example, security, as I already mentioned, it is quite important, because we need to take into account, for example, the possibility of machine learning in order to identify new kind of attacks, new kind of and way of reacting based on the different condition in that sense. So at the end, this is possible, as already was mentioned. I think also Ovidiu already expressed it, and Mark, I think on the previous presentation, we already have a lot of possibilities and technologies that can help us in order to do that. Now we have the challenge to start integrating all of them and try to solve this kind of new complex problems that we are going to need to cope in the future. So the integration of the AI, I was set on, and I would prefer, at least because of my experience, more on the machine learning. I was set techniques that we can use in this context can help us in order to obviously increase the local processing capabilities, obviously, and make it more smart, to do intelligent tasks, as I already said, of loading, to provide advanced coordination mechanisms between all the different layers and levels, specifically levels that we are having the decision process in that sense, to provide learning and adaptive capabilities to the devices in that sense, not only to the IoT, as I already mentioned, but also to the edge, in order to be able to take future decision or take decision in advance, taking into account predictive modeling in that sense. And all of them will allow this integration between the core, the edge, on demand, and in a very dynamic way. That is, I think, one of the also key elements that we need to cope in the future. No? So for doing it, we have a lot of technologies or tools, if you like, already was mentioned, federated learning. We have distributed edge computing providers in that sense. And for example, we have solutions like TinyML that will be also part of a later presentation from my colleague in that sense. So just to give you, I mean, this is just to show you some of the examples that I already was mentioned. I think it's not to go much more in detail than them. But the idea at the end is that we need to think about in a more abstract way to understand that different things or different operation can be carried out on different parts depending on the different capabilities, and we need to do the orchestration of all this process. That is, I think, it's the most relevant part that we need to cope in the future years in that sense. And obviously that's implied to be able to learn, to get data, to understand what is happening, and to take local decision, and to be able to decide when this local decision and how this local decision can be coordinated between one and the other in order to have a global, I would say, intelligence vision of the problem. As I already mentioned, one of the key topics here is about the dynamic security management of this kind of a scenario, because basically at the end, the changing condition imply different possible reactions that need to be happen in order to create defense in order to new attacks or new leakage that can happen in any of this point in that sense. So this is I would say that it was like the local, and this is the global, I would say, understanding, where basically all the different elements are integrated and are coordinated in a federated way, I would say, in order to provide the end-to-end experience of the user in that sense. So just to conclude and not to take more time, I think that one of the important things is that in this evolution that we understand is that we are going to have we are going to see an increase in the cognitive self-evolution capabilities of the different elements in the chain. So from the fog, from the edge, from the cloud, that will allow new visions also of how the AI would be able to be used on this kind of a scenario. In our case, for example, one of the things that we are thinking about is specifically linked to the connection between the IoT and the edge is what we call evolutive artificial cognitive capabilities that will be able to create, and based on the learning capabilities and machine learning capability, to understand new situation, to identify new scenario, and to be able to adapt and either to evolve basically the capabilities of the IoT and the connection between the IoT and the context where he is embedded. And I also already mentioned, just to finalize, important is this security orchestration that need to be carried out in this scenario. So to be able to, on demand and in a dynamic way, be able to deploy new security mechanisms that try to cope with certain kind of on-demand requirement coming from the different elements on this complete chain, from the IoT up to the edge, and that globally all of them could be able to cope with some kind of policy that govern what is the kind of security you want to manage on the higher context. So message here is dynamicity, intelligent reactive provision of services, and scalability of the solution based on the capability that the AI and artificial intelligence can bring out on this kind of a scenario. And
thanks, Antonio.
That's all from my side. Many thanks.
Thank you for the nice presentation. So we have time for one question, short answer from Antonio. So please, the first related to his presentation. If you need more time to think about the question, so then we move to the next speaker and prepare the question for the panel discussion. So the next speaker is Artemis Voulkidis, and he will introduce his concept related to applying distributed ledger technologies to energy-related context. So Artemis, the floor is yours.
Hi, Ovidiu. Can you hear me now? Hi, all.
Yes, perfectly.
Excellent. Many thanks for having me invited here. It's really delighted to listen to all these very, very interesting presentations. I was quite happy to see that Ovidiu also had several of the notions I would also like to present integrated in his own presentation. So it means that everything is, let's say, pertinent. So I'm here today to talk about the role of cloud architectures in applying distributed ledger solutions in energy-related contexts. So we have three things: energy, blockchains, and cloud-edge. Blockchains as, let's say, examples of distributed ledgers. So to start with, the energy sector is a critical infrastructure that is currently facing challenges. And it's particularly critical because it also affects other critical infrastructures. For example, imagine that a large part of the electricity networks goes down. Then there's no communications, there's no water. At times there's no transportation and all this stuff. The energy sector is also facing challenges due to the increased penetration of renewables. So we all like to have the EU Green Deal into the table and actually applied. However, when integrating more renewable sources, the result of that is actually to have instabilities in the power grid due to the lesser quality of the energy, let's say, that can be produced by renewables. This, combined with the notion of smart grids, opens the door to intelligent control. And this actually leaves the door open again to automation. I would say also to virtualization. The notion of the virtual substations is already there. So the bad thing about all this stuff is that cyber attacks are always there. They're more contemporary than ever. And opening the door to intelligent control and REST APIs and intelligent services, they render the energy mix and the whole energy sector situation a bit like a thunderstorm, let's say. But we're not sure whether actually it is. That's when the blockchains may come in. There are still examples of distributed ledger. They have several use cases. The most important ones, I would say, are the ones that I have bulleted here. So data non-repudiation and security guarantees. Smart grid control largely depends on timely, let's say, monitoring, and we can have monitoring guarantees at a later stage, let's say, by using the blockchains. We can use distributed identity schemes to avoid vendor lock-ins. Actually, with a spin-off of Synelixis and the work we did together with British Telecom, we also got an innovation award in this direction. And then we also have the transactive energy approaches that they are considered that they're the, let's say, the future of renewables integration in the current grid. Now, the real-time requirements are always pertinent, particularly when it comes to virtualization of energy equipment. So what we argue is that the cloud architectures coupled with 5G, as was mentioned before, it has not been sufficiently tackled today. They may come to the rescue and solve the situation. So the situation is pretty much obvious for everyone. Blockchain-related operations are usually computationally intensive. However, the field devices, the IoT devices, are generally not computationally capable. We're having some trials in Italy about smart metering, blockchains-enabled smart metering. The fact was that they were trying just to sign some data and send them to the edge to be processed. Signing took 37 seconds on average. So when talking about real-time monitoring of the grid, 37 seconds is, let's say, a lot. Adding on top of that, data security and the confidentiality are key factors. Energy data, they may be used to create profiles for the users. So privacy is ultra important in that perspective. So what we need to do is to keep local data local level and ensure data sovereignty. Now, the role of the cloud edge architecture and 5G is crucial when considering these challenges. What we can do definitely is to offload some computationally intensive operations to the edge instead of the cloud to make better use of the lower latency that the edge is promising. And as two examples, we can have blockchain gateways and digital twins, particularly their combination is the optimal way to go forward in this direction. So digital twins, as was mentioned before, should be considered, let's say, as virtual entities of a physical node on the cloud, on the edge. They appear to be good candidates to mitigate a lot of issues that the sector is facing. So we have low communications latency. We may have faster development cycles that can result in faster evolution of provided services. Hardware cannot be, or software hardware cannot be very easily updated, let's say, on the field. Faster development cycles based on northbound APIs of the digital twins may come for the rescue, let's say. We have chances for increased resilience, and they can also be treated as local data keepers. There was an interesting chat discussion before about AI on the edge and on the IoT. What I said was that AI-powered cloud-trained digital modules, let's say, in this particular example, digital twins, operate better at the edge because they support lower analytics latency, and they enable actually a closed loop integration of analytics and local control at the device level. So as a conclusion, let's say, there's no particular role in cloud edge architecture on top of the scenarios that we're mentioning, distributed ledgers and energy. Cloud edge architecture and 5G actually empower such scenarios. There cannot be a rational implementation of distributed ledgers on the energy without the cloud edge and the 5G. I hope I got some time, so I'll be glad to answer any questions.
Thank you, Artemis. very interesting presentation, and hot blockchains combined with Edge and IoT are a very important element and technology that actually will support many applications in the future. So, one question to Artemis related to his presentation. We have a very quiet audience. You can unmute. You have the control. So, yes.
Okay, I do have a question for you.
Please,
This is
please
probably very out there. With the whole digital twin.
Could you introduce yourself?
Okay. Hi, my name's Calvin. I'm from Australia. I'm just a student interested in all facets of technology and futurism ideas.
So please.
Yeah. So my question is, why is the concept of the digital twins based on binary technology, what we have now? Can it not be translated into quantum computing? Because the basis of that quantum computing is instantaneous transfer, near instantaneous transfer. What's the, why is there not a sort of translation into that sort of computing? That's my question. Thank you. Thank you, Adam.
If I may answer, that's a good and forward-looking question, actually. It might be too forward-looking in my perspective. Quantum computing could be the solution to the IoT paradigm, let's say. So as you said, instant communications without too much hardware, hopefully. It's way too far in the future in my mind. And when it comes to current technologies, when, for example, even 5G is at such nation level, it's, I guess, more down to earth to talk about digital twins rather than quantum twins.
Thanks, Artemis. So I think indeed this is a question that maybe we'll find an answer in the next 20 years.
Yeah, 20 years. Yeah, exactly.
But I think it's a good point. So we have to think that the solution today will be aiming for the development of the technologies in the future. Thank you very much. So we are continuing our presentations with Stefan, Vanya, that will introduce the concept from the vicinity. And Stefan has prepared the presentation together with Natalie. Natalie will join the panel. Stefan, the floor is yours.
Many thanks, Ovidiu, and many thanks in general for to present in front of such a wide audience. So let me to say a few words about Vicinity project, which presents an option for the decentralized interoperability of different IoT infrastructures. Basically, Vicinity is presenting a certain kind of decentralized interoperability as a service, where it uses a peer-to-peer architecture with open APIs to connect any kind of existing IoT infrastructure or services. That basically, Vicinity is not bringing yet another IoT platform. Instead of that, it tries to connect the existing ones together. So so the system integrators and device or infrastructure providers are offered with open APIs that they can use in order to integrate to the Vicinity. And once integrated, the infrastructure owners, infrastructure operators can manage the visibility of their data by other users themselves. So all their data are always under their control. So the whole organization is similar to the well-known social media, like where I can decide which photos, which statuses I'm sharing with which friends. In this case, all the users, the infrastructure operator can decide which IoT data is sharing with which other organization and in which time frames. So we provided a web interface for that, so certain that is hopefully relatively easy to use. Sorry. So such an architecture was supposed to introduce several added value for different stakeholders. We recognize that such architecture is well suited for complex multi-stakeholder environments like smart cities, smart regions, smart communities, and it can support evolutionary innovations which upon stakeholder consultations in the domains of smart cities and smart communities, we recognize that the innovative communities are doing a lot of experimentations, a lot of micro projects or projects with very small budgets in order to test the impact of different innovations. So such approaches are really well suited for such environments. Then for application developers, the decentralism tries to release the vendor logs that are still very often present between the services and infrastructures, where there are certain vertical silos by IoT vendors. And for the infrastructure operators, we see as important that the infrastructure operator is very sensitive for the data ownership. So therefore, we try to offer an option where they really can control who can see their data, and they can fully and to have a full control of the data lifecycle. Sorry. Nevertheless, so we recognize that there are still certain challenges, even in the decentralized environments that were tested or in the Vicinity project. So we, in the Vicinity, we gave the control over data to the user, but only on the user data level. The system still keeps the information on users' metadata. We recognize that for certain use cases, the privacy need to be extended to the metadata levels. It's very important, for example, for the personal and health applications. For example, if someone have an insulin pump or something, then even the existence of such kind of device is already a privacy sensitive information. Therefore, we need a further step in order to protect users' privacy on the metadata level. Then when we are talking about these open decentralized ecosystems, that was several times mentioned in the previous presentations as well. But nevertheless, so there is really certain issue with the governance structures and with the business models in such ecosystems. So it's still an open question how to organize the governance in a way that's not ruled by certain incumbent vendors, for example. So, and how to do it on the level of technology and not just on the level of legal agreements. And last but not least, and this is also part of the missing or unsatisfactory business models, is the question how to convince the data owners to share their data. So all these open ecosystems brings their value only in cases there are many data owners connected to them. But at this moment, certain arguments are missing, or hard, and therefore it's hard to convince the IoT operators, the data owners like smart city organizations and so on, or even others, in order to share their data, in order to be able to generate value on the data abundance on different levels. So thank you for your time, and I'm waiting for questions.
Thanks, Stefan. Very interesting approach. So, a question for Stefan on this new approach related to energy domain. Okay, then thanks, Stefan. So you will be part of the panel, so you will have the chance to answer to the questions then. So we move on then to the presentation of Antonello Monti and Alberto Dognini, and they will address the same domain, the same sector, and they will propose a different solution. So please, Antonello.
Yeah, thank you. This is Antonello Monti. I prepared the slide together with my assistant Alberto Dognini, and we also tackle the technology involved in proposing a solution for the energy systems. What I'm glad to see at this point of the day, after hearing so many other interesting presentations, is that at the end, when we look at these slides, I will go through in a few seconds, basically a lot of the greens have been mentioned before are finding here a common ground and I'm working together. My idea is to go through a set of results of a variety of a European Horizon 2020 project where my institute has been involved to show a sort of an evolution of our idea on how the grid management, particularly the level of distribution grid, can be performed. And I'd like to start with the project Sogno that we just closed a couple of months ago successfully. Sogno stands for Service-Oriented Grid for Network Operators of the Future. And as you can see from this slide, we imagine that to solve the challenges in grid, there are few ingredients that have to be brought together. And it's kind of nice to see these are the ingredients that have been presented in a separate session, maybe, or a separate presentation before. One hand, we have the need of low-cost sensors, so point of which we can acquire information. And this will be specific of distribution grid because cost will be an issue on one hand. On the other hand, we require high accuracy from this measurement because the distribution grid is characterized by nodes that are not that far away from each other. So that measurement has to be extremely accurate, and this is somehow already a challenge. Then virtualization on the edge of the intelligence. We propose a full virtualization of the substation automation and creating a standard architecture for the edge in which we can, in a modular way, plug in different services, and I'll have a little bit more about this. Other key ingredient in the project was the application of 5G for the data acquisition and for the edge management. The coordinator of the project was Ericsson, and then you can understand definitely how strong was their interest in understanding how 5G can facilitate and enable a grid distribution management. And last but not least, we also included data analytics and deep learning because one of the challenges is, even if we can imagine to put enough sensors, the classical model-based approach that are used in grids, like in transmission grids to operate, will not work in distribution in the future, because we will not have, from the point of view of a model-based solution, enough information to perform all the processing, estimation, monitoring that we need. And then artificial intelligence approach provide a way to be model-free and totally data-driven, which is, in my view, a key feature. And this was also proved in experimental activities in our field tests that we had both in Ireland, in Germany, and in Romania, in which we successfully brought these 4 ingredients together in what is our Sonio platform, that is a modular architecture that you see here structured in the definition of an integration bus that is in principle independent from the communication infrastructure and able to communicate with different devices on the electrical grid. And then a set of services that can be containerized and then integrated on the bus. Some of them will be sort of standard, like visualization and database. All the other services will depend on the specific grid operator and what they want to develop. This was the vision of the project, which, like I said, been successfully deployed. And now what I find more interesting is some of the grid operator involved in the project now want to continue independently from the Horizon 2020 funding on further expanding the platform that we implemented in the first version. At the same time, trying to get even more complete in this view, currently in a follow-up project called Platone, which is this idea to unify a platform, again, focused on distribution, grid operation. We added some other ingredients to the concept we developed before. So what you see in the middle, a DSO technical platform, there will be an edge-based solution, so that can be deployed both centralized and distributor or in a mix. This is totally possible in different grid operator may go for different combination depending on the complexity and size of the grid. We added 3 other elements. One, and I like to resonate with the previous presentation from Artemis, a blockchain interface to have the possibility to create trust between data that we can get from customers. It was mentioned also before, the need of customer involvement and customer integration, grid-oriented, service-oriented grid from, at the end, customer-centric. That's one of the key messages in restructuring our energy system. A link to the market, so to enable, as was mentioned in one of the previous presentation, local flexibility market that will be critical to keep the system operating versus the high volatility of renewables. And on the other hand, last but not least, in Platone, we're also developing a link to legacy systems. Was mentioned before, a lot of SCADA systems are still used. I don't think utility will trash them tomorrow. What it makes sense is to expand and create a platform like the one we proposed here that is distributed on the edge, totally open and flexible, but still integrated in the old systems. This is because, in my view, utility will accept to migrate services to this edge vision in time, but they will not do it from night to day. And there are some more critical services, at least they perceive, they should be done still the old fashioned, like protections. And these were probably the last one to migrate in an IoT type of approach. So I see this capability to combine the old and the new world as a critical way to build a good relation with grid operator and to convince utility to move in this direction without a real shock. Last ingredient that I would like to mention, again, resonating with a previous discussion, this doesn't end the need of expansion. So if you look at this slide, in the red, the DSO platform, you may say coming from the Sonio concept, then the yellow on the left, the third party means legacy SCADA. This is what we are doing in Platone. But as was mentioned before, when we look for flexibility, a very good source, no question, will come from a multi-energy view for the future. That means linking to other infrastructure, means bringing the electricity grid to also a broader view in terms of smart city. And then is necessary that the previous architecture based on a message broker will open up to other type of platform. In this respect, what we are doing in other projects is to use the fiber approach to bring this multi-energy smart city type of dimension so that the electricity infrastructure is not an isolated smart system, but is part of a smarter and broader concept of smartness that cover other verticals. And this is pretty much in line with the work of the project OpenDI that you see a reference here in this slide, which is exactly trying to look at this cross-domain approach and defining unified view for platform and data management in the specific in OpenDI, also going in a direction of agriculture, manufacturing, healthcare. But in general, from the energy perspective, means first of all, going out of electricity and looking really at energy as a first step. With that, I complete my presentation and I'm open for questions.
Thanks, Antonello. So one question for Antonello related to the solutions for energy market, combining IoT and edge computing. So if there are no questions at this stage, so thanks again, Antonello. So we move to the next presentation. We have Csaba from Digital Catapult that will present some of the work that is related to Tiny ML and how to use AI for IoT devices. So, Csaba, the floor is yours.
Thank you. I would share the screen if possible. I think the screen sharing is still on. Okay, yeah, thank you. Am I sharing the right one?
Yes, all good.
Okay, thank you. Yeah, so thank you for the opportunity to speak on this panel on enabling technologies. I'm Csaba. I was the technical coordinator of the Agile IoT API project, which was an IoT gateways previously, and now I'm in Digital Catapult. This is a Catapult organization in the UK, which means that we are in a unique position between policymakers, research, university research, industry, startups, and the investment ecosystem. And with the mission to help early adopters of advanced digital technologies. This includes startups, scale-ups, and the industry as well. So I think we all agree in what is in this slide that compute should move closer to the edge, as was pointed out already in the introduction by Max. How close is the key question, and it depends on capabilities in these 4 segments highlighted below. So the first is cloud segments. Is the cloud segment. Well, basically the previous IoT platforms were developed. Then there are edge servers, such as mobile edge computing, which is the edge if we are speaking to our 5G team. And then there are embedded computers at the edge. And here we are speaking of smartphones, IoT gateways, and embedded single board computers. And this is where Agile IoT was focusing, for example, or where the autonomous driving fits. But today I'm excited to speak about the last category, which is the edge. Well, we have a new computer revolution, which is taking place. So research and innovation is moving fast in this segment, both on development platforms and on a large variety of application domains. So the revolution basically that is happening, I would say in the last 2 years, is AI becoming a first-class citizen in the microcontroller space. The largest initiative is TinyML,
which was basically born from the on-device privacy keyword detection requirements in Google and other devices. It's a collaboration of Google and so what is driving this change and where we are today? I would say the first enabler is research around model compression. While many still think that to do AI, especially deep learning, you need huge models, what we see now is that using different model compression techniques like 8-bit integer quantization or even 4-bit integer quantization model tuning, we can go down to model sizes of below 2050 kilobytes. Actually, even down to even smaller models, tens and hundreds of kilobytes, and do inference on microcontrollers. The second technology enabler in this space is hardware architectural innovation. We have seen an example from previously. So on sensor AI embedded on the sensor itself, near memory computation, accelerating AI, in-memory computation. These are all technologies which are driving innovation in this space. And last, software frameworks. Software frameworks which are evolving. Main example is TensorFlow for Micro, which is now mainlined and available, and tool sets which are now start to support end-to-end development from different companies, from startups to large companies like ST. But these are the technology enablers. I would say even more important is the change in the programming of embedded devices. The new powerful data-driven programming paradigm shift, which is happening in the embedded space. And this is enabling new use cases, and it's enabling a wider developer ecosystem. So just to show you some examples of emerging use cases, there is a working group called TinyMLPerf, which is a working group started by Harvard, Stanford, Google, and many other actors, in which we also take part, which in the last year categorized and mapped solutions in this space and developing benchmarks. I will speak a little bit about later about this. And you can see different use cases which are already in development. And actually, for benchmarking purposes, we have selected 3 use cases: audio records, visual records, and anomaly detection. And for each of these, you have models which are easily fitting in on microcontrollers in tens or hundreds of kilobytes. So I would say the future of compute is tiny. There is compute in the very edge, and many of the compute can be moved there. And as I think Harold highlighted, cost is a huge issue, and this is where things are coming in, where microcontrollers are coming in. We are speaking of a large number of billions of devices which are already deployed, and we are not speaking of things which cost more. We are speaking of a new generation of microcontrollers, which are more or less in the same price range. So wherever you have now a microcontroller, you can imagine in the next generation a microcontroller which can do AI. And we are speaking of a price segment which is even below $1 or in the range of $1 to $10. Another dimension which was mentioned often is energy. And this is actually a very important point. And let me highlight that now we are in a situation where we can do image classification, for example, in less than a millijoule per inference. So each classification is less than a millijoule. If you compare to that, to the energy that you would need to transmit that image from with your RP1 technology of choice, let's say LoRaWAN, you would easily spend tens or hundreds of millijoules to send that image. So processing at the end is absolutely important, and actually it's the balance is changing now thanks to the new capabilities on the microcontrollers. And also to highlight the amount of data that is being generated, there have been studies that the amount of data that is generated in a single factory is more than the data in a single day, is more than the data which is generated on Twitter in a single day. So for obvious reasons, you would like to process things as close to the edge as possible. And now this is becoming a reality. So I'm reporting here some examples of early adopters. These are just representative examples from different companies from the EU and from outside. So one very nice example is people counting using infrared sensors or using images. And this is, for example, an example from Greenwaves, which is going low power, battery operated solution. Another example is autonomous drones, where such controllers can be used. And this is, again, using a low power controller. Or an example, which is always on voice commands, which is an example where it is really a small AI enabled, but not even AI enabled, but specifically developed for AI purposes, low power device, which allows you to run vehicle detection for running a long time on battery operated, enabling devices to have better interfaces. So in the space where we work, where is the research, what are the research and innovation priorities? I would say what we do at Digital Catapult to encourage innovation is we work on standardizing performance benchmarking through the Tiny MLPerf working group, which is very important in the current phase. In the current phase, there are a large variety of hardware solutions, software solutions. Heterogeneity is enormous, also on the power budgets, which are considered below milliwatt, below 10 milliwatt, below 100 milliwatts, depending on the use cases. So having a standard performance benchmarking is important, and we are working on that. We are working on accelerator programs for startups and scale-ups, which we see very important, simply because the domain is not very well known to companies, and technology development, working on time, on mobile edge computing, and on federated learning. In the long term, big picture, I would say what is important is to really enable data-driven innovation, which is enabling previously untapped domains. So if you think of domains where microcontrollers were based on doing threshold-based logic that has a few parameters going up to some kilobytes of parameters, and AI, you can do much more, and you can train those models based on data that is available and enable a lot more. In research directions, it is on the long term, it is important to develop sustainable energy neutral devices, which are kind of deploy and forget. But it's also important to see how these devices fit in the large orchestrated sync to cloud continuum. How they integrate in, for example, in a federated learning scenario, as it was highlighted previously by one of the other presenters. And also maybe a bit even more longer term direction is from inference, which is happening today in these devices, which we can say is intelligence, it's AI, but it's just a complex function, to low power learning, which is not yet here, and how we move there, and how through low power learning one can go to real intelligence, context adaptation at the very edge. So with this, I would conclude my talk, and happy to see questions.
Thanks, Csaba. So what I will suggest that now we invite the speakers in the panel, the virtual panel, including Natalie, because I received a message from Mirko that was the other speaker that he could not join the session, but he sent the presentation and this will be available for you to look at it. So I will invite the speakers to join now the virtual panel, and I will start with a number of questions to the panelists, and then we will open the floor for questions to the audience. So first of all, I would like to thank you for your presentation. So the presentations show actually how broad it's this field and how many challenges we have. And then I will start with a question related to added value. What is the added value of integrated IoT, industrial IoT, and edge computing solutions? I would like you to be very specific and give one example based on your experience and the one that you consider most important. So again, added value of integrated IoT, industrial IoT, and edge computing.
I was last to finish. Yeah, I'm not muted. I was the last to finish, so maybe I can start on that. Let me take one example, which is predictive maintenance. So in that space, the added value of having edge compute processing huge volumes of data in the industrial sphere, but not just predictive maintenance, also product quality assessment through images, through accelerometers, through different kind of sensing techniques, and processing this vast amount of data already on the devices in first instance, and then in edge servers is, I think, a huge added value.
Yeah, I mean, sorry, because I was muted, Antonio. I mean, from myself, I mean, and based also on the experience we have on some concrete deployment that we are having, for example, all the scenario now of vertical farming, for example, that introduce a lot of complexity on the management of the different, I would say, subsystems that need to be coordinated in order to cope with the global problem, because it's not only just monitoring, it's actuation, it's a different system for the irrigation, for the fertilization, for the different aspects. And I think the most important part here is where, I mean, this combination of IoT and edge is clearly provide added value, is the capability to provide different kind of decision making. I would say there are certain decisions that are very, I would say, need to be close looped to the actuators, and I would say, because they need to be very short in time, low latency, etc. Other ones can be more global in the sense that can be more strategic, if you like. And that combination is only possible if you allow this kind of aspect that I already mentioned about how to make the distribution of the computation in one sense, but also how to intelligent decide what can be done in each of the different places in that sense. Also, for example, when we are talking about greenhouse vertical farming, because it has certain complexity, but for example, greenhouses and massive deployment of greenhouses, I mean, it's also some very interesting scenario where to apply this technology.
Thanks, Antonio. Antonello, please.
Yeah, I can add something from the energy perspective. I would say in this case, more than added value is a necessity. So the system, as was well presented also before, particularly from a colleague from DTU, you know, we are moving from a situation in which we had a few large power plants to a solution in which we have to orchestrate millions of devices. And so any other solution in which we don't keep the data local and then the process of this data local will simply be impossible. So it's not just a question of value added, it's just the enabling technology in this case, in my view.
Maybe to build onto this point, can you hear me? Antonello, fully agree on the context, and to add to that, we need to build new infrastructures and infrastructures on the edge. If we don't focus on one area, then we will have to build additional infrastructures, not only on the edge, but in the intermediate level and the clouds. This is at this stage, I think, too complex of the task, and giving the limited resources that we can dedicate to that, I think that's another consideration. So the edge would constitute one type of infrastructures, but if we don't focus on this, we are losing two things. We're losing the customer engagement, and for the energy communities, for the peer-to-peer energy, for distributed intelligence or the nodal approaches, which are expected to provide the flexibility, but not only flexibility, as well as the energy efficiency and other benefits. So we cannot not to focus on this. It's already big enough of the task. So if we need to build larger hubs for energy share, or even go upstream, I think it's just too much of the economic commitment to everything. In addition, I would like to add an additional dimension. If energy is not complex enough, now we are stepping into the environment of sector coupling. Now it's called smart sector integration. I think Antonello already mentioned this dimension, which used to be somewhat simpler, because when we were talking about coupling, we were talking about mobility, smart energy distributed devices, generation, and things of this nature. Now the world became more complex, and we're talking about power and all the vectors versus just one related to the electricity. So the architectures and the role of Edge for this integrated and holistic picture that you can see in the Vision 2050 of the TIPS-net is more complex, and I think for the future research area, it's one of the areas that we need to focus and see how we can extend the current architectures and how the distributed edge could play within this environment.
Thanks, Natalie. So now, in order to
if I may add as well, sorry, Ovidiu.
Please, Artemis.
I would also, from my perspective, say that the edge has the potential to transform IoT. IoT is great, many capabilities, many things to do, distributed intelligence. The cloud edge actually renders IoT real time, and it renders IoT interactive. So the one thing that was missing was, together with 5G, low latency, ultra quick and reliable control. And now with the advent of 5G combined with smart edge, now this is actually possible. Not only monitoring, but also control in general.
Thank you very much. So I will fire a number of other questions to you. So the next question is related to enablers and platforms. So what IoT and edge computing enablers have you used in your experience, and you consider them key for the future development and integration of these two technologies? And on the platforms, what IoT and or edge computing platforms you consider for different industrial sectors, and how you envision the development of these platforms in the future?
From my side, I would still go for the digital twin side. So we have used the digital twins in the energy domain. They are actually working. There are great open source tools as well. So one thing to notice is that IoT may be driven by open source, and that's a good thing. Now, regarding the different industrial sectors, I guess always it actually depends. It depends on, for example, if you are having an automotive industry, perhaps you would try to have a platform based on the automotive, on the car maker, let's say, that provides the car, something like that. I don't think that there is a one size fits all, particularly when it comes to the edge. And this is actually one of the core constraints of all this effort. Different hardware requires different controllers. Different controllers require different vendors, and different vendors require different platforms.
I mean,
thank you very much.
Sorry, from my side,
yes,
I mean, just to complement, yeah, it was just to complement some of the stuff. I think that I absolutely agree. It's quite difficult to say one or the other in that sense. But for example, depending on the context, no? But in our case, for example, just to mention that, for example, when we are talking about the orchestration, I mean, the use of platforms, open platform, if you like, that facilitate to work with a kind of heterogeneous environment. That is the kind of things that we are going to have in the future. are the key enablers in all this case. Also, for example, was mentioned previously regarding the energy, some kind of generic operating system, that can be applied in some way to facilitate the process. I think that these are the things that at the end will help in order to really solve this kind of issue. For example, for orchestration, in our case, in several projects, we are using solutions like Mano and how this can be integrated on different orchestration of the component for the security components, I would say in some sense. For example, we are using, in case of platform, in this case, some enablers coming from Fiverr, like Fogflow, for example, that allow you to do an orchestration between the cloud, the IoT, and the edge, and be able to provide distributed capability of processing in that sense. So I think that there are different combinations that maybe will really, but in all the case, should be something that is allow the virtualization, I would say, of the softwareization of most of the functionality to have all the flexibility to really be totally independent as much as we can. I would say independently of the hardware component. I would say. Yep.
Thank you.
I can add on the same direction that our experience, the one I represented in my slides, apart from referring to some famous architecture like Fiverr, I think what is the main lesson we learn in building the solution is the role of open source. So having available and easy to access a set of open source tools, the platform Sonio that I showed that we built in the project is basically a combination of open source solutions. We didn't have to develop anything from scratch. And then critically is also the interface and the API definitions, because when you have open source solution and standardized API, then you can really play a Lego composition game, which allows you to quickly develop solutions. So to me, these are the two key ingredients that allows quickly to have solutions available.
Perfect. Then I will go for a few other questions related to
just Stefan speaking. One very quick.
Yes, please.
Very quick thing for these platforms, for the integrating some everyday IoT things like Philips Hue things or IKEA ones. There is a very good open source platform, the so-called Open Hub, which facilitates the integration to dozens of different well-known IoT ecosystems. So if someone is interested in it, I would really say that this should invite should visit the webpage of Open Hub.
Perfect.
So one from me, if you don't mind.
Yes,
I just highlight.
We have a few other questions, so you have to be very brief.
Yeah, just besides open source, I would highlight the open source foundations, the role in having a set of compatible open source solutions in an ecosystem that you can use quite nicely. Linux Foundation, Active Foundation, other foundations. It's interesting to do that. Yep.
Perfect. So then we have two sets of questions that I would like you to answer very briefly, so we can go as well to the audience for other questions. So first of all, obstacles and lesson learned. What are the obstacles to build integrated IoT edge computing systems and applications today? And lesson learned, can you share some lesson learned in your experience about integrating IoT edge computing in the domains in which you apply the technologies?
I can take this question. Hi, everyone. I'm Poonam.
Hello.
So I think it's an interoperability is one of the biggest issue, heterogeneity, device heterogeneity, data heterogeneity. For example, like Csaba said, we are working on TinyML benchmarking group, and where even the data coming from these different devices, because there is no standardization right now, there are different format. How you can enable like federated ecosystem, everything, different devices, different data formats, how it's very hard from without a standard. That's what I thought. It's very important we come up with some kind of standard so that everything could be integrated with each other and we can enable this federated kind of or distributed learning framework.
Thank you very much. So other points of view?
Cost, I would say cost, as was already highlighted, is a very important barrier in which there's work to drive it down. But when you are speaking of large amount of devices, where you think whether to add one button, you really have to drive down the cost of these solutions. That's an interesting area.
I will add also additionally. Already mentioned previously. I think the idea of how to maintain a certain level of security on this kind of heterogeneity in that sense. So at the end, if you are in a closed domain, it's you can manage basically. But when we are talking about multi-domain, multi-technologies, guarantee a certain level of security. All the process is quite complex. I would say it's one of the key challenges I would say we can have in this environment.
If I may also,
everyone, just be mindful.
Okay. One word: connectivity.
Yeah, exactly.
On security,
lack of 5G.
Also the long-term aspect. So speaking of devices which are long-term deployed, the security, how you handle the security on
yes, the matching these investment cycles and expectations for the, we're dealing between critical infrastructures, 25, 50 years, right? And then we deal with the edge, which is totally different ball game. And here the governance also is different. So.
Perfect. So then I will fire the last set of questions, which are related more to what we should do, what objectives should be set in context of vertical industry to improve EU competitiveness around IoT and edge computing. Where do you see European strength, and which industries and sectors are most mature to adapt new business models based on IoT and edge computing? The first movers. Very brief, maybe in 10, 15 seconds for intervention, for each intervention.
I don't know, maybe I can start. I think in the energy sector, we are well positioned from a set of reasons. The first of all, because we are approaching the energy transition in a way that, for example, in the US is not happening at all. And in that sense, we understand the problem way better. We have a tradition also of research of energy that is not equivalent strong in the US. And then we also, a lot of the big industry in this sector is also European, different from other sectors, ABB, Siemens, to mention Schneider, to mention some of them. So I think it's a sector in which we have a unique position from experience and an industry. And in that sense, we are very well positioned. The question is, if these big guys are moving in this field with enough flexibility to follow these changes in transition.
So now you took a commitment. You will convince the stakeholders in the industry to invest.
Every day.
Thanks a lot. So other points of view?
From my side, I would say that the strength of Europe is definitely polyphony, but this is also its drawback. So I would go for standardization. Objectives should be set towards there, particularly perhaps when it comes to interoperability across sectors. Regarding the industries, of course, I agree with what Professor Monti said. I would also go for non-critical sectors like gaming and perhaps robotics in some cases. And what was actually quite interesting, and I was really glad to hear, was the mention about security. So security and security over IoT cloud edge, so security companies.
Okay, thank you very much. Other?
I have very brief ones. Scaling up is one of the challenge. There is lots of innovation on the SMEs, on the startups level. So the harmonized penetration across the member states, I think, is one of the challenges that I think we can address in the nearest future. This is one of the handicaps. And also the potential discussion, I'm talking about the energy sector specifically right now, or the cross domain between the smart cities, energy and mobility. to address the climate change. So here we can go faster, I think. The other dimension would be linked to the separation of the critical assets and the services that the energy sector can provide, because if we're not dealing with the hard to solve topics of security and stability and things of this nature, I think we can go faster with the edge deployments.
Thanks, Natalie. So it seems that our time has passed. It's 5 to 4. I got a message from Martin that we have to be sharp. So what I will propose, because we didn't receive any other questions in the chat, if you have questions, please contact the speakers, contact us as organizers, and we will come back to you with answers to your questions. So now I give back the floor to Martin, and thanks again to all of you for participating and contributing.
Thank you, Ovidiu, and thank you everyone, both to the presenters and the audience, also for being so broad in what you cover, so deep. Actually, I think we had some really nice deep dives, which was, of course, the purpose of the afternoon here. So just a few observations from my side. I give Max you the floor to conclude here today. So it's clear that technology cannot just be pushed out there and it will work. Of course, we need to work across, well, the quadruple helix, if you want, the private, the public, the knowledge institutions, very much represented here in the last section. And then, of course, civil society, which has a very, very strong position in the European strategy as it's coming up now. You know, there's this joke, you probably all know it. So what does it mean to be connected on the internet? So these things, what are they connected by? And the joke is, of course, well, if you have a network time protocol capabilities, you can be connected. Otherwise, you cannot. So the question is, of course, while this is not precise, how much of this vast Internet of Things needs to be synchronized? Yeah, because that creates actually a lot of dilemmas. I mean, we heard just now about the decoupling actually to be able to move faster. So what you said, Natalie, we also have so the sovereignty versus the economies of scale. So lots of dilemmas in there. So of course now we need to translate that into technology, but of course also into governance, and certainly into timing, which is very much what NGIoT does. So we will work to highlight the priorities that we hear from you, but broadly from Europe, inspired by the world. So priorities, we will facilitate, like in this session, the community. We had, you know, hundreds of people here, so that's really encouraging. And then the last thing, create a roadmap with priorities and timing together with you. And if I may come back to the point that you made in the beginning, Max, so certainly, yes, we do have research, we have the market and society, and we have an urgency. So speed is of the essence. So again, timing of what to do when is really what we will focus on now, together with those who want to be engaged, and of course together with the Commission. So so this doesn't look very much like Max, it looks more like Rolf, but you have the floor, Rolf, to conclude here. Wow, Max, you're here as well. Okay, right. Over to you guys.
Yeah, thanks, Martin. I think first of all, I was impressed. It was a very stimulating event today. Many thanks for the speakers and the presenters. It also has shown that it's a very interdisciplinary domain. I think we've seen from the sectors, there are strong needs, particularly driven by the decentralization, moving automation and decisions on a decentralized level and keeping information and data on a decentralized level, which sort of represents complete paradigm shift from what we have today on the central topologies and cloud architectures. But said this, it doesn't make things easier. It's certainly cost disciplinary. It has to be bringing different technologies together, from IoT, AI, cloud data, 5G, embedded microelectronics. But we also see the paradigm shift for IoT. So moving from monitoring and connecting things to outcome-driven and automation, which completely also, a new challenge and also a shift for IoT community. I think what we learned today, I think I will not go into much of the details, but we've seen that, we want to avoid that raw data goes to the cloud. So many of the data is processed locally, transformed into knowledge, information. We've seen the trend on more intelligent sensors, which combine with AI, and keep the confidentiality of the data and still provide insight into the processes and in all the pre-packed information. We've seen trends emerging in mobile edge and new opportunities. We've seen the different flavors of architectures from fog, deep edge, far edge, whatever, who sort of start describing the paradigm shift and the different concepts, including, a guardian angel or stochastic methods or the tactile internet. So all that together, represents a community, a new ecosystem, a new challenges for research. And from our point of view, from the Commission, I think we want to avoid that there are new islands or silos, that we ensure interoperability and roaming, that we keep an eye on federated learning as well. We keep an eye on the energy consumption, the energy in the context of decentralized architectures, and in particular, to build on advances in AI in one way, AI at the edge, AI to have the decisions locally pre-processed, and we've seen some challenging approaches in that one. So that brings me to the end. I think we need to sort of define what we mean by orchestration between cloud edge on the one hand, using swarm computing, virtualization, and meta operating systems, but at the same time also to keep the strong attention, on the innovation and development on the device level, keeping end-to-end security, looking at new standards, looking on open software, open hardware, and don't forget to see what is the added value for European industry. What are the business models? What sort of investments are needed into infrastructure? And what can we do on the regulatory side or on the side on bringing public money into the game in order to bring stakeholders together, partnerships, and drive innovation that we gain speed and adoption. That brings me to the end, and I pass the last word to Max. Thank you.
So we have to change seats. Okay, so thank you very much for this very interesting workshop. What I can say is, being new in the unit, I've learned quite a lot more than what I knew. You heard me in the beginning speaking. I have seen, for example, that now that it's a two-directional thing from cloud to edge, but I also see that that's what we see more intelligence at the edge. But on the other hand, we also see what we in particular saw in the cross-cutting section, that we see a federation of edge resources to support the cloud. So we see on different levels, on edge cloud level or cloud level. So we somewhat see both directions. Obviously, I was more looking at the one more intelligent devices in the beginning. I followed the workshop the whole day, which normally is an indication we normally don't take our time for that. So I think it was very, very interesting for me to look from the application side. So first, in particular, those applications that I personally don't know as much as, for example, manufacturing. So energy, automotive, well, that's what I know. Smart cities, farming, food chain, also the link to the food chain. So it was very interesting for me. I see that there is a demand from these applications for the movement from cloud, for the trend from cloud to edge, like the demand for decentralization and also the need for intelligent sensors, but also intelligent devices in general. So yes, that's important. The question now is, how quick will that all go? And how can we, as we are good in the edge or in the application, how can Europe how can that help Europe to position itself better, and what can we as Commission do or to strengthen our EU players, be it through research, be it through innovation, but also be it through platform building or politics within the EU policy and within what we are doing anyway in terms of the digital strategy that we have announced. So that's basically the homework that I take from here. I have to see what we, together with Rolf and colleagues, what we do, what we need in this direction, also together with the other units who are responsible for the cloud policy or for the smart network policy or for the key digital technology policy. So thank you to NGIoT, the CSA. Thank you to IoT. Thank you to all the people who have helped organizing this. I don't name them because I recently ran into the problem. I named some and I forgot some, and that's always bad. So I don't name anybody. But thank you to all of you. I'm very much looking forward to a report which we can make available so we can share what was discussed today with some others. So with the ones who are interested from the European community. So thank you very much for this very interesting event, and with this I stop. Thank you.
Thank you very much, Max. We will report on this and we will share with everyone. I think we should give everyone a hand, if we can do that, even coordinated or not, over the net.
Yeah.
So we continue. Thank you, everyone, and look back to the website, the NGIoT website. We will share the slides, the recording, and of course the report. Thank you, everyone.